This lesson is on normal distribution. What makes a distribution normal? The four examples we see in front of us are distributions that are not normal. The one on the top left is an example of a skew right. The one directly below it is a left skew. The one to the top right is called a bimodal distribution. And the one on the bottom right is a uniform distribution. There are certain characteristics that a normal distribution has. 1. Normal distributions are symmetric around their mean. 2. The mean, median, and mode of a normal distribution will be equal. 3. The area under the normal curve is equal to 1. 4. Normal distributions are denser in the center and less dense in the tails. 5. Normal distributions are defined by two parameters, the mean and the standard deviation. 6. 68% of the area of a normal distribution is within one standard deviation of the mean. If you think back to the examples that we had for COMPES, we noticed that one standard deviation above and below the mean represented about 67% of the COMPES. 7. Approximately 95% of the area of a normal distribution is within two standard deviations of the mean. Also in our COMPE example, where we did notice that it followed a normal distribution, we noticed that two standard deviations from the mean was approximately 95% of the data. This is what a normal distribution curve will look like. It is less dense in the tails and denser in its center. The area will equal 1. The mean and median will be equal to one another at the center. It's symmetric around their mean. It's going to be defined by two parameters, the mean as well as the standard deviations. And on the next slide, you'll see the empirical rule. This is the mean at the center. And you'll notice that from the center, we have one standard deviation above and below, which represents 68% of our data. Two standard deviations above and below the mean represents 95% of our data. And lastly, three standard deviations, which we did not see in our COMPE example, would actually represent 99.7% of our data. Using normal distributions. A normal distribution has a mean of 27 and a standard deviation of 5. Sketch the curve, labeling mean and standard deviations. Find the probability that a selection will lie within the given interval. Let's start with a sketch of our normal distribution curve. Given this sketch, we know that the mean will equal 27. And we're told that the standard deviation is 5. 27 plus 5 is equal to 32. 27 minus 5 is equal to 22. This would be one standard deviation above and below the mean. Two standard deviations would be 27 plus 10, which is 37, and then 27 minus 10, which is 17. And lastly, three standard deviations from the mean would be 27 plus 15, which is 42, and then 27 minus 15, which equals 12. In letter A, between 22 and 32, between 22 and 32 would be exactly one standard deviation away from the mean, which would equal, using the empirical rule, 68%. B, between 12 and 27. Although it does look like it would be about half, it's not exactly 50% if we use the empirical rule. We know that from our previous slide, we saw that 99.7% of our data lied within three standard deviations of our mean. So using that same piece of information, we know that the tail ends beyond the three standard deviations would include 0.3% of the area under the curve. 0.3 divided by 2 would equal 0.15. So if this half is equal to 50% and I subtract 0.15%, I would be left with 49.85%. C. Between 17 and 37. 17 and 37 include exactly 2 standard deviations above and below the mean. The empirical rule states that that would include 95% of the data values. D. At least 22. At least 22 means 22 and above. I know that everything above 27 would be 50% of my data. I also know that 22 is 1 standard deviation away from the mean. If 1 standard deviation above and below the mean is 68%, then that means 1 standard deviation below would be equal to 34%. So that means between 22 and 27 would be 34%. So the total, at least 22, would be 84%. Please go ahead and do letters E and F on your own and be prepared to share your answers in conference tomorrow. Example 2. A college only accepts students who score in the top 16% on the entrance exam. The scores are normally distributed with a mean of 25 and a standard deviation of 3.8. To the nearest whole number, what is the least score you could earn and still be accepted? I recommend starting off with the normal distribution curve because we're told that the scores are normally distributed. The mean is 25 and the standard deviation is 3.8. We want to know the top 16%. Everything below 25 would be 50% of the students. Between 25 and 1 standard deviation above the mean, like we saw on the previous slide, this was equal to 34%. That means that the top 16% would be everyone above 1 standard deviation above the mean. That would be the top 16%. So to the nearest whole number, the least score you can earn, that would be a score of 29. 3. At Irvine High School, a survey revealed the mean amount of soda consumed each week was 12 bottles and the standard deviation was 2.8 bottles. Assuming that the survey is normally distributed, how many bottles of soda per week will approximately 68% of the students drink? Again, we know that this is a normal distribution. We also know that the mean amount of soda consumed was 12 bottles with a standard deviation of 2.8. 68% of the students, according to the empirical rule, is 1 standard deviation above and below the mean. So that would be all the students that are in that highlighted section. Therefore, we can conclude that 68% of the students drink between 9.2 and 14.8 bottles of soda per week. One of the most common examples of a normal distribution is the distribution of scores on standardized tests like the ACT. In 2010, the mean score was 21 and the standard deviation was 5.2. The source in which we found this was the National Center for the Education Statistics. Use the information along with the empirical rule and the approximate area under the curve to sketch a normal distribution curve for this test. Here is a rough sketch of a normal distribution curve for the ACT scores. Question 1 is, what percentage of students scored below 21? Below 21 would be everything in this half of the curve. This would be 50% of these students. Question 2. About what percentage of students scored below 16? Now going back to my normal distribution curve, 16 happens roughly around here, and I would try to find the area under this part of the curve. It's difficult for me to find the exact area as of right now because all I know is the empirical rule, so I will have to estimate to the best of my ability. If I know that this half is equal to 50%, one standard deviation would be 34%, then that means that this remaining highlighted section is approximately 16%. Three, about what percentage of students scored between 11 and 26? Going back to my distribution curve, 11 is about right here, 26 is roughly here, and I'm going to find the area under the curve between 11 and 26. Again, I can't fully use the empirical rule. I can use that to help guide me find a good approximate. And there are several ways you can do that. Using the empirical rule, what I would probably do is state that between one standard deviation above and below would be about 68%. This is close to two standard deviations below the mean. If I know that two standard deviations above and below the mean would be 95%, 95% minus 68 would be 27. And 27 divided by 2 means that this portion here would be about 13.5%, making that about 81.5%. In order to properly answer questions 2 and 3, we will have to wait until next class so that we have a method in order to find areas under the curve, not using just the empirical rule. 4. Pulling all of the data for test takers is a time-consuming and expensive practice. If we draw a sample instead, what do you think the mean will be, and how confident are you in that value? To answer this question in terms of confidence, we are 95% confident that the mean will be somewhere between 10.6 and 31.4. I can also use the one standard deviation and three standard deviations, so I could also state that we are 68% confident that the mean is between 15.8 and 26.2. And we can also state that we are 99.7% confident that the mean is between 5.4 and 36.6. 5. Your friend Calvin would like to go to a very selective college that only admits the top 1% of all student applicants. Calvin has good grades and scored a 33 on the test. Do you think that Calvin's ACT score gives him a good chance of being admitted? Explain your answer. In order to answer this question, we could say he's close, but we're only able to approximate it right now. Like I mentioned earlier with questions 2 and 3, we need some kind of better tool other than just the empirical rule in order to answer it as accurately as we can. In other words, we need a tool that will allow us to find exactly what percent of students Calvin is above by getting a score of a 33.